Zero Trust architecture represents a shift in the paradigm of cybersecurity, moving away from traditional perimeter-based defenses towards a model where trust is never assumed, regardless of origin. This introductory approach breaks down the core principle that underpins Zero Trust. Never trust, always verify. By scrutinizing every access request as if it originates from an untrusted network, Zero Trust architecture ensures rigorous authentication and authorization before granting access to resources. This subsection lays the foundation for understanding Zero Trust architecture, providing viewers with a clear overview of its basic concepts, its departure from previous security models, and the rationale behind its increasing adoption in the cybersecurity realm. The fundamental premise of Zero Trust architecture centers on a simple yet transformative principle: never trust, always verify. This approach dictates that no entity, whether inside or outside the network, is trusted by default. Instead, every access request is treated with suspicion and must be verified rigorously before access is granted. This verification process involves not just who or what is requesting access, but also scrutinizes the security context around that request, taking into account factors like user identity, device health, and the specifics of the requested resource. By adopting this mindset, organizations can significantly enhance their security posture, ensuring that access is carefully controlled and that their networks and data are safeguarded against both external and internal threats. This fundamental change in approach reflects a deep understanding that in today's digital age, threats can come from anywhere, and security must be agile and comprehensive to be effective. The key components of Zero Trust architecture are crucial for its implementation and effectiveness. These components include identity verification, ensures that only authenticated users or devices are granted access. This involves rigorous identity proofing and management processes. Device security evaluates the security posture of a device before it can access network resources. This includes checking for security updates, anti-malware protection, and other security measures. Least privilege access restricts user access rights to the minimum necessary to perform their tasks. This principle reduces the potential impact of a breach by limiting access to sensitive information. Microsegmentation divides the network into smaller, secure zones. This allows for more granular control of traffic and limits the lateral movement of attackers within the network. Automated security policies utilizes automation to enforce security policies dynamically. This ensures that access decisions are made in real time based on the current security context. Continuous monitoring and response involves ongoing surveillance of network activity to detect and respond to threats promptly. This includes analyzing user behaviors, assessing device health, and continuously evaluating the security posture of the environment. Each of these components plays a vital role in the implementation of a Zero Trust architecture, working together to provide a comprehensive and dynamic security framework that adapts to evolving threats. The shift towards Zero Trust architecture emerges from a critical need for a new security paradigm, addressing the limitations of traditional perimeter-based approaches in today's interconnected digital landscape. In conventional security models, once inside the network perimeter, users and devices often had broad access, operating under an implicit trust that made internal systems vulnerable to threats from both outside and within. However, the rise in sophisticated cyber attacks, insider threats, and the increasing adoption of remote work, cloud computing, and BYOD, bring your own device policies, have rendered perimeter-based defenses insufficient. Threat actors can now bypass traditional defenses with relative ease, exploiting any weak link as a gateway to wider network access. Zero Trust addresses these challenges head-on, eliminating implicit trust and requiring verification of every access request, irrespective of its origin. This shift not only strengthens security measures, but also aligns with the modern decentralized business environment, where users access systems and data from various locations and devices. The adoption of Zero Trust represents a recognition of the evolving threat landscape and the need for a security model that is robust, adaptable, and capable of protecting against both current and emerging threats. This video series will guide you through the evolving world of cybersecurity with a focus on Zero Trust architecture, a paradigm that assumes no inherent trust and demands verification for every access request. We will embark on a journey from understanding the basic principles and components of zero trust to exploring its necessity in the face of today's sophisticated cyber threats. Along the way, we'll delve into the practical steps for implementing this architecture, highlighting the enabling technologies, addressing potential challenges, and illustrating real-world success stories. By examining the present applications and envisioning the future of cybersecurity, this series aims to provide a comprehensive roadmap for navigating the complexities of zero trust, ensuring that viewers are well equipped to adopt and advocate for this crucial security paradigm.